So we're going to apply prims to a matrix, or distance matrix, which represents the sort of graph we've been looking at in order to find a minimum spanning tree. So, reminders again. Let's try and do this verbally this time. Just tree.
A tree is where all vertices...
It's a something.
No, that's a spanning tree.
Yep.
So a tree just connects, like is a connection between two vertices, but not a closed cycle or anything like that.
It's a connected graph.
A connected graph.
Yeah, it's a connected graph. You've got the right picture of a tree in your head.
Yeah, I know exactly what it looks like.
Yeah, you know what it looks like. It's just the words. It's a connected graph with.
A connected graph with no cycles.
Exactly.
Right.
Connected
so
graph with no cycles. Yeah, that is what a tree is.
Yes.
Now the cycles are the round and round thing.
Yes.
The connection is that there's a path between every two,
Yeah.
but a tree is just a connected graph with no cycles.
Yeah.
Yeah, and yes, you do have to know what a cycle is, and a cycle is a closed path,
path,
and you need to know what closed means, and you need to know what a path is, and connected, what does it mean for a graph to be connected? All the points are connected, what does it mean for vertices to be connected? So yes, all of that, but the definition of a tree is a connected graph with no cycles.
Yes.
Spanning tree.
That's where all vertices are included.
Yeah, tree with all vertices from the original graph included. So everything's included. So it spans the original tree. Minimum spanning tree. Spanning tree such that.
The weight is at a minimum.
What about the weight?
The weight of the total
Total,
weight.
that's it. Minimum total weight. Yeah, okay. So what we're going to do first, I'm going to build a matrix from this graph. So what this is a way of just showing the graph but in a table form. So we start by putting lines across here. That means A is not connected to A, B is not connected to B, C is not connected to C, and that's because we haven't got any loops. So a loop looks like this. That would be C connected to C, and we're not going to have any loops. So we definitely don't have a problem with C not being connected to C, okay? So, can you fill in the distances in the distance matrix? So how is A connected to B? 8, yeah? Is there anywhere else that's also on the distance matrix got the same piece of information?
What do you mean the same bit of information?
Well, this is B connected to A, which is the same as A connected to B.
Okay, so no.
So we've got A.
Oh, so A connected to B, sorry.
A connected to B, yeah? Same piece of information. A and B connected.
Okay,
so every number that you put on, you can put on twice.
Right, I see. So A to C, do I have to add them up? Yeah?
A to C, is it direct?
No.
No then, just put a line. Because this just shows direct links.
Right,
That's
okay.
it, yep.
So A to D, that's 5.
Yep.
That means A to D is 5.
Yep.
And A to E, there's no direct link. There's no direct link.
Yep.
B to C, 4.
Yep.
And B to C, 4. B to D, no link. B to D, no link. And B to E, where is it?
In the middle.
Yeah, 3. So B to
Yep.
and C to D is 7. C to D is 7.
Yep.
And E to C is 1.
Yep.
So that's 1. And D to E 6.
Yeah, perfect. Okay, so we're going to do prims. And because we've already done prims on the actual graph, we're going to try and see how it connects to the matrix. And then we'll just purely do it on matrices.
Okay.
So where do you want to start? What's your favourite?
No, C.
C. Okay, so we're going to start at C. So C is in our tree. It is our tree so far. And what we do is we put a 1 at the top of there because we've now brought C in. Okay? Now, we need to connect either A or D or E or B to C.
Yep.
And we want the cheapest one possible.
So
now,
E.
if you look at the actual graph, you can see that there's a 7 connecting in, a 1 connecting in, and a 4 connecting in. Okay? If you look down this column, there's the 7, there's the 1, and there's the 4. So this column down here represents the things connected into that particular one. So if we were looking at the graph, we'd go, right, 7 or 1 or 4, 1.
Yeah.
Yeah? Looking down here, 7 or 1 or 4, 1. So we do a big circle, I accidentally circled the other ones, but yeah, we choose the 1. Yeah?
Yeah.
Now, what was it really important with prims that I write down?
the order.
Yeah. So what have I? If I look at this, what is it I've chosen?
C to E.
CE1.
One.
Yeah. So which node have I now brought in?
So you brought in C. And
I had
brought
C
in
originally.
E.
I
Yeah.
brought in E. So E came in second. Okay?
Right. Okay.
Now looking at our graph, now we would now be looking at, if I get rid of all the things I've scribbled on it, we've got C in, we've got E in.
Yeah.
Now we could bring in D that way, or D that way. We can't bring A in. We could bring B this like this, or B like this.
Yeah.
So we would be looking at all those connections, seeing which one's cheapest. Now on the matrix, what that is doing is looking down this column at the 7 and the 4, and looking down this column at the 3 and the 1 and the 6. How come I've got a 1 there and I wasn't looking at this 1 here?
Because that was the connector.
Yes,
here.
that's that connector. So what we do, so that we're not looking at too many things, when we have brought in the C, we just cross off this whole C row so that we're not looking at things twice. Because you know everything occurred twice, but I don't want to look at that as well as that and consider it twice. So I've crossed off all of E, meaning C is already in my tree. Now E is in my tree now as well, so I don't need any of these connections here. Because I don't want to try and bring E back in, I've already brought E in. Okay, so I can bring B in at a cost of 3, looking down the E column. I can bring D in at a cost of 6, that is this 6 and this 3. Or I can bring B in at a cost of 4, that's that 4 there. Or I can bring D in at a cost of 7, that's that cost, that one there. Right. Smallest is 3. So I look down both of those, find the smallest. Remember to write down what I've just brought in. B. That means I've now brought B in third, which means B doesn't need to be brought in anymore. Okay, now I've still got A and D needing to come in. So if you look at your actual graph, you can see that we would want to bring A in on 5. Is that right? No, because we haven't got D in yet.
But if I look at my matrix anyway.
What's the smallest thing you can see in the columns so we've got column 1, we've got a 7 in it. Column 2, we've got a 6 in it. Column 3, we've got an 8 in it.
Exactly, so we need to go back to E.
So E, and bring D in, 5 and 6.
Oh, sorry, there's a 5 here.
Yes, there is a 5, but look where 5 is on our... Because this is our tree at the moment. Our tree, so we have to bring into the existing tree. So our tree at the moment is... What have we got? C to E and B to E.
It's not in any of our columns.
That's, exactly. So we've got 3 columns we can look down. We've got the E column and the C column and the B column, meaning we can connect into those.
So
and the cheapest one is the 6. So the 6 in there. So we bring in the D. The D's come in next. What we're on 4. Don't need to bring D in anymore. Now I can look down all 4 columns, because I can bring A into anything, because everything else is in. Cheapest is 5.
Do we need to write down our...
Very good point, very good point. What did I just bring in? D, E, 6.
So we've made 3.
And now A, so that's that one. 3 edges, 4 nodes. And now A.
And then A... So,
Which is this 5 here.
Yeah.
And then that brings in your AD at cost of 5.
Okay.
So, you are doing exactly the same. You're considering the same things, choosing the smallest, bringing it in, not having to worry about cycles. It's just all on the matrix.
And when you're doing this, are you mainly looking at, you are looking at the matrix really, aren't you?
You don't have the graph usually.
Yeah.
You only have the matrix.
Yeah.
So, this is my little algorithm. It's not, what's it called? Whatever they're called. Where you thing.
Can't remember what they're called.
That thing. So, we start with the top.
Acronym.
Acronym, that's the word. So you label the top. So if we choose C first, put a 1 on the top of C, then the row gets removed.
Yeah.
The one that we just labelled, remove that row completely. Then we put a big fat circle around the smallest.
Yeah.
Now this is the smallest under any in any labelled column.
Okay.
So any column that is labelled is a node in the tree. We can connect into any of them.
Yep.
So you have to look down all of the columns that are already labelled and find the smallest, circle it. Okay? Then list, list. Okay? This is the important thing to get the marks, which as you saw I just forgot, which I genuinely forgot just now. Write down the list of the order in which you're choosing stuff. So your BE6 and then your FE12 or whatever.
Yep.
Get that list together, because otherwise you're not going to get any marks. Okay? So, let's have a go. No, this is the one we just did, isn't it? We've done that one now. Do you want to? No, let's do another one. Okay.
Wicked.
So, start where you like.
Right.
Start with the top. T for top.
Right, so I like to start with C.
Okay, so you put a 1 up there.
So I put a 1 there.
Okay, now R is for remove the row. Remove the row C.
Yep, so we go across.
O is for circling the smallest, which is under anything labelled. Good. And then L is for listy list, get the marks.
So we get C to A.
Yeah.
And that's worth 12.
Good.
Which means
T.
I've brought in...
Now we're on T again.
Yep, so I've brought in A, haven't
Good.
I? So I can cross out A.
Yeah, that's it.
Can I cross out as 12 as well?
Not,
Because it's a bit confusing.
I think you can cross out the 12 as well.
Yeah,
I don't think
that's
it's a problem.
confusing me now. So that's number 2, and then I
Because
can
you've
look
got
down...
your list down here, so...
Yeah, exactly. So
Yeah.
I can look down
So you're
column
now...
A and column C.
Yeah,
for
that's
the
right.
smallest number,
Yeah.
so 23.
Yeah, that's the smallest.
So I'm going A to D now,
That's the list.
23.
Yeah. T for top. What did you just
T
bring
for
in?
Top. I've just brought in a D,
Yeah.
so that's 3. So
Yeah.
I go along with D,
Yeah.
cross the whole thing
Yeah.
out, and again pick the smallest number.
Put a circle around the smallest.
15.
And did you look down all 3? Yes. Did you?
yeah.
Yeah, good. Okay.
So that's D
And
to
then
B.
you get your list.
So
Yeah.
that's 15.
Yeah.
And
We
I
need to
brought
extend a
in B. So that's now 4. Cross out
Remove,
4.
circle, look down
So I've got
all
1 to
4.
4, 75, 87, 71
Yeah.
for the list of it.
List.
And then B to E, 71.
Yeah.
Brought in E, that's
Yeah.
the final thing.
Remove E row.
And that's done.
Done. Like it?
Yeah. And that's really nice.
Yeah, exactly. So actually, I think Primm's on the graph is harder than Crystal's on the graph, but I think Primm on the matrix is easier than either of them.
Yeah.
So the main, these two are now in your pack, so you can have a go at these and then pause the video. I'll put the answers up in 1 sec. Okay, so here is the answers. So yours should be absolutely identical to this, again, unless I went wrong when I was doing them. So check carefully that your list is identical and that your ordering numbers at the top is identical as well. Oh, that's... Did we have any? What could go wrong? Oh, well, this is just a reminder of... This is actually quite important. When you get to the end of your algorithm, and you've got this list of the arcs to bring in, and you've got the weight of the tree. So the total weight of the tree, the minimum spanning tree, is 10, add 13, add 2, add 5, add 6, add 3, and then you add all of them up. Then the most common mistake to make, where people lose a mark, is that they add them all up and write 480 to... Oh, this one didn't even add up right.
Right.
Okay, so that is one issue.
Yeah.
Literally adding up wrong. And then the other common thing, I don't know whether I've got an example, is units.
Right.
Going back, D1 is really heavy on units. So if you, yeah, there you go. So really common, add them all up. The weight is 595 watt.
Yeah.
Kilometres, grams, units of something, whatever it is. So go back to the question really and always check the units on D1.
Okay.
Good.